Dear colleagues, let me introduce our report, Collaborative Decision-Making Models for Flexible Manufacturing Robotic System. It's presented by Oleksandr Tsymbal and Artem Bronnikov from Department of Computer Integrated Technologies, Automation and Mechatronics of Kharkiv National University of Radio Electronics, Kharkiv, Ukraine. Idea of robot collective applications in execution of command task is popular for a long time, but it became more realistic only with rise of mobility and autonomy of robots. While stationary industrial robots usually don't need any collaborations, mobile robots must be adaptive to workspaces to supply execution of paths, avoiding collisions, physical or logical, to objects, humans, and other robots. For case of single mobile robots, there is no collaboration to other robots, but static collaboration to workspace. But functioning of several mobile robots in common workspace is more complex task, which can be solved by introduction of centralized control system, which takes into account all generated paths of robots, separates the zones of robots' activity, prevents collisions, makes queues for common service points, defines orders of robots' application for complex tasks. Implementation of such control system can be critically difficult without multitasking, and every single task can present independent robot. Therefore, there is need to shift to more autonomy of robots, and as a result, their full autonomy. Certainly, here we can ask different questions, like what is the level of intelligence should be provided for every robot in common workspace? Would robots be more closer to humans or to ants in their collective behaviors? And must be form of robotic collaboration like to humans or to ants? And answers to this question devise ideas of robot control system organizations. And some researchers mostly consider first idea and some others. Current paper proposes logical models of collective decision-making of robots and of workspace for robotic functioning. Analysis of problem considers really different forms of communications between the robots with centralized and decentralized controls. Different works considers architecture of such system based on centralization, decentralization, differentiation, communication, and ability to model other agents and projects. And such system like actress, worm, gopher, aliens consider such collaborative system from point of view of resource conflicts, consider the origins of cooperations and learning. Also, other approach is evolutionary robotic techniques and plan-based control for human-robot activity and methods of decentralized control. Usually, researchers consider different phases of decision-making for collaborative robots, including the searching phase, deliberation phase, and commitment phase. All the phases, all the parts of robotic collaboration concept are considered. In our article, we can consider the logical approach. What does it mean? First of all, there is the workspace of flexible integrated system, which contains stationary and mobile technical equipment. And there is intelligent robot like IR1, which exists in workspace, and the intelligent robot IR2, which exists in workspace. There is also possible to define other intelligent robots, IR3, IRN, exist in workspace, while not considered in presented model. Functioning of intelligent robot 1 is considered to be controlled by decision-making system DMS1, able to produce action set A1, consisting of particular actions A0, A, and -1, to reach goal set G1 with sub-goals G0, G, and -1. Correspondingly, second robot IR2 is considered to be controlled by decision-making system DMS2, able to produce action set A2, A0, AM -1, and to reach goal set G2. G2. Robots IR1 and IR2 can be of same time of functionality, and we should consider their compatibility for actions and goals. Their actions and goals should be just compatible and equal. While programming of various intelligent robots can be different in common case. In usual conditions, robots work independently according to their tasks and goals, G1, T1, G1, T2, generated by control system and present in combination of G1 and G2. Independent functioning of IR1 with DMS1 and IR2 with DMS2 is possible if goals generated by control system are relevant to actions or series of actions. But it's also possible that control system generates another set of models, G3. The particular sub-goals GK3 can be operations between particular goals of corresponding robot and present particular actions for corresponding robots. And the operations between Z goals can be set by plus minus multiplication division of such goals at level of compatibility of them. Correspondingly, serial setting of collaborative goals defines corresponding plan of robotic collaboration P3. Including sub-goals and the set of goals G3 and actions A3. So we can consider collaboration of particular robots R1 and IR2 like a result of their common operations, common actions to receive common goals. So collaboration between intelligent robots can be set of levels, their property, compatibility, additive manners of goal and actions. Besides, here description of workspace plays a great role and must have corresponding description. Really, such approach can be considered by a form of predicate logic, and also consider it in our paper. And you can see it in the report presented in the materials of the conference. Other part of our research is the development of information logical model of robotic workspace for flexible integrated system. The main idea of a distributed robotic system here is to control a group of mobile robots to perform one or more tasks. So for case of practical implementation, here is proposed that one robot should take the role of master and the rest of robots should be slave. Consideration of such approach is impossible without workspace model. The objects should be considered. Here, inside information logical model, workspace considered with the set of robot RB1, RBN, which can work inside it. Workspace can be described by a set of properties like geometrical dimensions, the set of space belonging objects, and time intervals of every object and workspace existence. Correspondingly, workspace can be described like with a form of set consisting of D objects and T, and Here, every element of such workspace can be described by unique identifier, and identification of such object can be provided by using by barcodes, QR codes, landmark, etc. Certainly, a problem of such model is dimension of model, and for case of flexible integrated system, certainly it's finite, but for open workspace it can be infinite, and it makes a number of problems of such model description. Another aspect is monitoring of such workspaces, and they are considered a number of methods how to monitor workspaces by distributed camera systems. Discreteness and division of workspace also very important for description of step-by-step decision making, and here is proposed another approach. Our workspace is considered like sum of sets of geometric and other parameters. Important parameter here is a coefficient of filling of every cell of such workspace, and we should consider it from point of view of existence of objects inside workspace, instruments, equipment, humans, robot, storages, possible conveyors, and devices to monitor our system. And the corresponding elements of this model are described. A collaborative group of robots can be also considered like a set, in this particular case RBS, which can be included to the description of our model, consisting of workspace, robots, and other elements of equipment required in our model. Graphical description of this model is presented here, and you can see that it consists of storages, humans, robots, conveyors, other parts which are characterizing our flexible integrated systems. Considering hardware and software to describe this model, we should say that distributed computer vision system are one of the best choices in this path. Such computer vision system can get information about environment in form of images, and we will need to process, analyze them to obtain the necessary data. To compose such system, we need a set of cameras, lighting devices, web servers to process such information, and devices there. Some particular task will be also executed. To implement such software, we are using OpenCV software library. Correspondingly, application of computer vision system makes a group of robots more flexible to share information between different computers, between different models, and to construct decision making possibilities for particular robots and for whole system. As one of the particular tasks considered in this project, we were considering one robot following other robot or other objects, for example, elements of workspace, and in this case, we are considering the concept of master-slave algorithm, then a robot follows some object or other robot inside workspace. Um, Such system is possible to implement even for simple model. Here you can see Raspberry Pi based system, including actuators presenting motors, including sensors here, ultrasonic sensor, but easily you can also join computer vision system. To implement this following algorithm, we can use algorithm scheme presented here, and here is implementation, program implementation of this algorithm. Therefore, in this report, we have considered current trends in robotics and the applications for different fields. Collaborative robotics becomes more popular, applying different methods, including swarm methods and methods of parallel or serial solution for multi-stage decision making. And really, researchers should make some variant of choices among these different methods, or to try to compose them together. Proposed paper considers models of collaborative decision making based on theory set theory and predicate logic, and this paper includes a description of groups of robots and their decision making, description of workspace model implemented by sample hardware and software systems. Monitoring of state of flexible manufacturing system is proposed to supply by distributed computer system, and where were developed some prototype of software. Their basic features of problem solving and workspace monitoring are tested. In future, these software models will be expanded by more detailed introduction of subordination of robots in a team, their internal technical motivation to reach better results for a flexible integrated system. Thank you for your attention. I will be ready to answer your question. Thank you.